The next one is on types of catalyst. So types of catalyst are homogeneous. Homo means the same, and genius has got to do with the chemical or the nature of the chemicals. So effectively that means that the homogeneous catalyst effectively means that the chemical or the reactants and the catalyst are in the same phase. Now a lot of the time people say the same state. You can't say that. But look, for all intents and purposes, we're leaving it is the same state. But you need to say that it's a phase. So that means that either they're all liquid or they're all gaseous. And obviously, solids is not really an appropriate thing to have both the reactants and the catalyst as a solid. So I'd forget about solids. But homogeneous really refers to either all the chemicals or the reactants and the catalyst being liquid, or the reactants and the catalyst being gaseous. Heterogeneous catalyst. Hetero means different. So that means they're in different phase or state. Now I can't really say state, but because you need to use the word phase. So heterogeneous would mean on one phase or a different phase. So that would be like what you do for junior cert when you put solid manganese dioxide into liquid hydrogen peroxide. So there's a lot of hetero in a catalytic converter in a car. The gases, I'll show you that in a second, but that's effectively a device that converts harmful gases into less harmful gases. Autocatalysts are effectively where the product of the catalyst or the product of the reaction acts as a catalyst. And we looked at this when we did the potassium permanganate experiment. When you add potassium permanganate initially, the purple color disappears from, actually we haven't done it yet now that I think, but potassium permanganate and iron is an example of an autocatalyst. It's where one of the products of the reaction acts as a catalyst. So the start of the reaction is slow because there's no product, but then one of the products acts as a catalyst. I'll go them through now in a little bit more detail. Homogeneous, this is when they are in the same phase. See what I mean? You need to say phase. And there's no boundary between the reactants and catalysts. That means they're all either liquid, all either gas, and we'll leave it at that. I wouldn't apply it to solids. An example is the iodine snake experiment. This is potassium iodide. I was going to show you this as well. Obviously, we're in school. You can Google it if you wish. You can see good videos of this online. If you pour the hydrogen peroxide in on top of the iron or the potassium iodide, you get this iodine snake. Effectively, both of them are liquid. So that's why it's considered to be a nice example. The oxygen given off and the water, you add some washing up liquid to this and this causes it to rise upwards. That's all that is. Type 2 then, heterogeneous catalyst. Heterogeneous catalyst, this involves the use of a catalyst in different phase or state, more commonly said, but don't use the word state as I keep saying. The examples use a solid with a liquid, or a liquid with a gas, or a solid with a gas, and that's the type of thing. Hetero meaning different there. The decomposition of hydrogen peroxide, what you do for juniors, is a lovely example of heterogeneous. Solid manganese dioxide powder, and you did this last week as well, or a couple of weeks ago in the experiment, and then you have liquid hydrogen peroxide. Autocatalyst is the third one. That's a really interesting one. It's where the product of one of the products acts as a catalyst. But you need to think about that. That means there's no catalyst there at the start, but as the reaction goes along on its own a little bit, and then one of the products acts as a catalyst, and the whole thing gets much quicker. And potassium permanganate and iron, you can change that to iron to be much quicker. Mechanisms for catalysts, the intermediate formation theory. This is a different thing now. So they're types of catalysts. I'd ended there.